I'm currently in the orthographic projection module that I assigned students to take a look at a couple of days ago. And I asked you to take a look at these YouTube videos on orthographic sketching and multi-views. Hopefully you've done that at this point and you've taken a look at this PowerPoint as well. I want to take a couple of moments and look over the PowerPoint and just want to discuss a few certain topics here. So, orthographic projection multi-view drawing is a system of drawing views of an object using perpendicular projectors from the object to a plane of projection. Meaning that when you look at an object, in this case, it has a width, a depth, and a height. And if this person is looking at it straight on at the front in full 2D perspective, this is what you're going to see. He's only going to see this surface through the hole and 1, 2, 3 surfaces here that swing around as a radius on each side. We're going to skip over history and we're going to take a look at projection of an object. So all of these projectors basically protrude out to give you a two-dimensional view on any object that you're looking at, right? Whatever's in your line of sight, right? So this is how it starts. You look at the object in this direction, and then the plane of projection basically jumps out at you, and this is what you see in your sight, right? You're just going to see those normal surfaces that your eye is observing at that time. So the glass box, which just by description is a little hard to understand. So it says that imagine that the object you are going to draw is positioned inside a glass box, so that the large flat surfaces of the object are parallel to the walls of the box. From each point on the object, imagine a ray or projector perpendicular to the wall of the box, forming the view of the object on that wall or projection plane. Well, to me, that description is hard to understand. But when you look at it, a picture is worth 1,000 words, much more than this. So this is what the glass box looks like. So imagine the object is inside the glass box, and all of those surfaces project to the faces of the box on all 6 sides. So we can have a possible of 6 views normally when we look at this like this. And typically we have 3 views that are the most important. We have a front view, a top view above, and a right side view to the right. So unfolding the glass box, if we unhinge it in a certain way, so unfolding the glass box for third angle projection, which is the method we use in Canada, imagine that the walls of the box are hinged and unfold the views outward around the front view. This will give you the standard arrangement of views for third angle projection, which is used in Canada and some other countries. So when you unhinge that glass box, as you see beginning to happen here, this is the order of the views you'll have. So you'll have your front view in the middle, which is basically the parent view, which is considered the dominant view above all the other views. It usually shows the most information. You have the right side view to its right, and you have your top view above, your bottom view beneath, your left side view to the left, and your rear view to the extreme left. And this is the order for third angle projection, 6 views. And this order is always going to be in this order. This is never going to change. And you notice that all the views have to line up with one another. So the center of this hole lines up with the center of the hole on every view, in line with it from top to bottom and horizontally through. Same with where the views begin at the bottom, where they finish at the top, where they begin on the left, and where they end on the right. This slot is no smaller or no larger than the slot that's shown in 2D perspective on the front view, and vice versa. So all the views just can't be thrown on a page somewhere. They have to be aligned. It's very important. The standard arrangement of views. So here we have another example, the same example with a car. Although this is a view of the front of the car, this view typically shows the most information. Its profile, so it is in the front. Why must views be arranged so that they align? To make it possible for someone to interpret the drawing. We're gonna skip over transferring dimensions and using a miter line. And necessary views. So a sketch or drawing should only contain the views needed to clearly and completely describe the object. Choose the views that show the shape most clearly, have the fewest hidden lines, and show the object in a usual stable or operating position. Right? So a shaft like this is normally horizontal. We normally show it in its operating position. This is one view drawing of a shim. And I call this a shaft, but same thing, it's a connecting rod. Position of side views. An alternative position for the side view is rotated and aligned with the top view. First angle projection. Now this is something that we're not going to bother with. It's just arranging the three views in a different order. So basically this is something that's seen more in Europe. So comparing symbols for first and third angle projection, that is the symbol for third angle projection that you would normally see on a mechanical drafting title block in industry, and the basic three view alignment minus the 6 views. This one, the symbol is slightly different and basically inverted, and the top view is at the bottom, the front view goes above, and the right side view goes to the left of the front view. So if you ask me, our symbol and our third angle projection that we use in Canada is easier to understand. I think it makes a lot more sense. So in summary, the 6 standard views are often thought of as produced from an unfolded glass box. Distances can be transferred or projected from one view to another. Only the views necessary to fully describe the object should be drawn. So that concludes the PowerPoint. We're going to go back one. And we're going to take a look at this sheet right here, orthographic projection surfaces example. And this is just another sheet for reference, a picture drawing. It shows an interesting object here that has all the surfaces numbered, right? So every surface has a number, and these arrows are pointing to the possible 2D views, the basic 3 views. So we have top, front, and right side. So when we look at this from a 2D perspective from the front, we're only going to notice surfaces number 1 and number 2. When we look at it from the top, we're going to see surfaces 2, 4, and 5. And when we look at this from the right, we're going to see surfaces 3 and 5. Even though this is on an angle here, looking at this from the right side view, we would have no perception of that angle, only its height that would look flat to us and straight up. Same thing with the number 2 surface. Even though it's on an angle, from the front view, it would appear to be going up straight from that perspective. And to prove it to you, so here's what we see. When we see the top view, again, 2, 4, 5, looks like a rectangle. Surfaces number 1 and 2, and surfaces 5 and 3. Obviously, we get a perspective of the angle on the right side view here. So this is the basic 3 views that we're basically going to spend some time on. And you're going to notice that even in the YouTube videos you watched with the woman sketching all of the views, she did the same order of arrangement. She did this as a top view, a front view, and a right side view. And she did them in this exact same order, and everything was lining up. The only thing she doesn't use is a ruler, which is too bad. Okay, so we're going to take a look at the practice worksheet. Now, what I'd like you to do is print this off. This is 2 pages. You can print this off on your printer at home, preferably. And basically, for the block, the slider, the tongue, and the step guide, you're going to be producing the 3 basic views. So the top view, front view, and right side view in this order. There is room for these to fit in these grid blocks if you do it correctly. So there's an example done for you at the top of the sheet here. So it shows basically this step guide here. And it shows how you can get this started. So you can draw the most exterior perimeters in rectangular form and then slowly define all the features. And then lastly, you could erase the lines that you don't need and complete it. So it doesn't have to be done exactly like this, but this is basically a very step-by-step process on how you can begin and get to this end result basically by looking at this example, right? So this is top, front, and right. So, like AutoCAD, there's an origin to start in every example. So you're going to start with the front view in this example, and this has to be done to scale. So your origin, you can imagine it right here on this 3-dimensional looking block. And looking at it in this direction is the front. Looking at it from this direction is the top, and this direction from the right, as you see my cursor flying around the screen. So you're going to count 1, 2, 3, 4, 5 grid lengths, and you're going to go 1, 2, 3, 4, 5 on the sheet of paper. That's going to be your length. You're going to come up 1, 2, 3 for height and come back and finish that rectangle, and you're going to count 1, 2 squares to place the vertical line here. Now, how many spaces should you leave between views? I would say leave 1 grid space. No more than 1 grid space is fine before you start working on the top view. And again, you would draw the top view. You would go 1, 2, 3 squares, come over 5, down 2, back 3, down 1, and back to finish. For the right side view, you would leave 1 grid space so the views aren't jammed up against each other, and you would draw another rectangular block that's 3 squares high by 3 squares down and back, and then leave 1 vertical line to show this rabbit joint in here, this notch out. So you're going to do that for every single example here. Remember, they have to be aligned like you've seen in the YouTube videos, like you've seen in the PowerPoint, and like you've seen in the previous slide, the image I just showed you for the picture drawing. Now, when you get to the last page on the back, this shows a glass box example. So this has to do with the PowerPoint, where you see the object in the glass box, and you have to basically cut and unhinge all 6 views, right? So when you unhinge this and fold it out, this is that same arrangement of views that we saw in the PowerPoint, 6 views. Again, you have your top, front, and right side view where they need to be. You have your bottom view at the bottom, your left side view to the left, and your rear to the extreme left. And again, there's an origin here. So if you do this correctly and you leave 1 grid space between all the views, you are going to have everything fit perfectly on this grid. So here's your starting point for the riser piece. Here's your origin. So imagine this is your front view here, looking at it in this direction, and then your origin is sitting here. So you're going to start with the front view, and you're going to draw 3 squares up, 4 squares over, down, and back, and you're going to put a little vertical line in the middle here to complete the front view. Same thing with the machine key. Now notice I put the origin offset a bit. It's offset by half a grid space because when you look at this, it's 1, 2, 3, 4, 4.5 squares. So basically, because this is the front view, looking at it in this direction this way, your origin sitting somewhere around here, you're going to be drawing half a square plus 2 plus 2. So you're going to come half a square, 1, 2, 3, 4, and then you're going to come up 2, back 2, up 1, back to here, and all the way down. Right? So instead of me, it's kind of tricky to explain a little bit, but I think you can basically understand what I'm saying. So I want you to try this at home, and so I want you to print this off on your printer and see if you can complete it. And I'd like you to use a pencil to do this, preferably, and you must use a ruler to do this to keep your line work straight. So remember, keep line work straight. Use a ruler at all times. Don't freehand it. You'll have a very much easier time if you use a straight edge. And lastly, I know that this has a bit of a radius on it, which might be a bit difficult to freehand, but if you have a drafter's template or a stencil of some kind or a compass you can use from your math kit, you might be able to easily sketch that semicircle perfectly. But if not, just try to freehand it as neatly and as best as you can. Remember, this isn't a race, so don't rush through this. I'd like you to take your time and do this correctly. And then I'd like you to submit your results to the Dropbox if you're working online. And if you are coming into class, I'd like you to bring it in to me to take a look at, please, the next time you're in class on your day. That's it for now. Good luck and talk to you soon.